Good day, everyone. This is Orekoya Olusegun, mathematics, physics mathematics fundamentals on YouTube. Today, the segment we are going to have on my YouTube is mathematics, and the topic is derivation of formula of a parabola. Now, when we talk about parabola is a special curve that is described by this condition. Like for instance, let's think about a fixed straight line. Fixed straight line, fixed straight line, and also an arbitrary fixed point f. This particular point f is fixed, so this f is called focus of the parabola. Now let's take arbitrary point p on the plane, anywhere on the plane. This particular arbitrary point P is described by its location along the x-axis and along the y-axis. So the x and y, they are known as the coordinates. Now, what I want us to also realize is this. According to the definition of a parabola, it stated that the distance of this variable point P that I have here, let's call it D1, and the distance of this variable point P from the directrix, this fixed straight line, let's call it D2. The parabola says that the eccentricity of the ratio of the variable point P from the fixed point F, the distance, so the distance of this variable point P from the fixed straight line, that is D2, is equal to 1. Now, I want to remind us of how to determine the distance between 2 points on a straight line. Let's call this one point P1 and this place point P2. The coordinate of point P1, let's call it S1, Y1, and the coordinates of point P2, let's call it X2, Y2. Now, let's say the distance D between these 2 points is D. Using the concept of Pythagoras theorem, D square is equal to the change in X axis square plus change in Y axis squared. Change in X axis means x2 minus s1 square plus y2 minus y1 square. That is my distance d square. But if I'm getting d, it's going to be the square root of this. So that means for me to get d, I must know the coordinate of this endpoint. The same thing is what is happening here. For me to know the distance d1, I must know the coordinate of this fixed point f, and this particular coordinate too. I must also know the coordinate of a point here to be able to get the distance d2. So how do we do that? Now, first thing I want to do is this. If I draw a straight line through this focus, let's call it this straight line, let's call it x-axis. Now, every point that follow this condition will lie on a curve, and that curve is known as a parabola. So that means every point I have on this curve, the distance of these points from the focus divided by the distance of this point from the directrix, the ratio of this distance must give me 1. The same thing with any other points I have here. Now, the particular point, the place where this axis x cuts the parabola is called the vertex of that parabola. And this line that passes through this focus is known as the axis of symmetry, axis of symmetry of the parabola. So what do I mean by axis of symmetry of the parabola? This particular axis behaves like a mirror. If you put a mirror here, the image of this particular portion of the parabola will be shown here. So they will look like identical twins. So, and then here, if the distance of the focus from this vertex is taken as a, before I move further, let me draw the vertical axis y through this vertex of the parabola. This is d2, so this height y here. the coordinates of this v on this x-axis and where it intersects the y-axis will be 0, 0. And then the distance of from this in our definition of parabola, the distance of the variable point P, that this particular point here, to the focus must be the same thing as from that point to the directrix. So if this one is plus a, then this place will be minus a. Now, having gotten that, the coordinates of f will be 0, a. Why? Because the distance of f along the coordinates will be a, 0. Because the distance of this f along the x-axis is a, and the distance of this f along the vertical axis is 0, because the f is not being lifted along the vertical axis, so the value will be 0. Now, I've gotten the coordinates of the endpoint of length d1, that means distance d1. So for the distance d2 here, I want to find the distance of this point to this directrix here. Since from here to this place is x. If you look at this along the x-axis, then from here to here is a. So total distance of this point to the direction will be a plus x. So now, if I want to get the coordinates of this point D, this particular point here, we know that the distance along the x-axis is this a, and along the y-axis is y. So I've obtained the coordinates of the endpoint of this distance d2. Now, if I want to get the d1, this particular one, I can use this formula to get it. So my d1 will be square root of, if this one is my x1, y1, and this is my x2, y2, then I have x as my x2 minus s1 is this a that is here, minus a square, plus y2. y2 for this particular place is y, then minus y1. y1 will be 0 squared. So d1 now can be simplified as square root of x minus a square. Y minus 0 is 0, so we have a plus y squared. Then the distance d2 that I have here, I have the coordinates of the endpoint as ay and xy. This particular ay supposed to be negative because it's on the left side of the x-axis from the origin, so it's going to be minus ay. Now, I will substitute the coordinates of the endpoint in this formula too. If I call this place remains as s2, y2. Let's say this one is s1, y1. If I substitute these coordinates in this formula that I have here, my x2 is x. So I have x minus my x1 for this place is minus a. So minus a squared. Then plus my y2 here is y, minus my y1 here is also y. It's also y. Everything squared. So this thing can be simplified into square roots of minus times minus will give us plus. That is s plus a squared. Y take away y will give us 0. So everything here will reduce to 0. So now, according to this relationship for the parabola, I can cross multiply. If I cross multiply, my d1 will be equal to d2. d1 is equal to d2. That means these two formulas will be the same. So I can equate this formula, square root of x minus a square plus y square is equal to square root of x plus a square. To remove this square root sign, I can square both sides from the law of indices. When I square both sides, this square will cancel this square root sign. So leaving this expression, x minus a square plus y square is equal to x plus a square. Now, I want to expand this and this one. Expanding this one now using binomial theorem will give us x squared minus 2ax plus a squared. So then plus this y squared that I have here is equal to, by using binomial theorem for this one too, if I want to expand, I'm going to have x squared plus 2ax then plus a squared. We can see that a squared cancel on both sides of the equation, and x squared to cancel on both sides of the equation. So I'm left with minus 2ax plus y squared is equal to 2ax. If I take this minus 2ax to this other side, become positive. Therefore, y squared will now be 2ax plus another 2ax, which is 4ax. So y squared is equal to 4ax is the equation of a parabola so that the vertex is on the origin 0, 0. If the vertex is not located on the origin, like when I have something like y and x, but the vertex is no longer at the origin, let's say the vertex is somewhere here at the having coordinates hk. In that case, when the vertex is not at the origin, like what we have here, we can manipulate this equation. Like say vertex is located at a point hk. So this equation can be rewritten as y minus k squared is equal to 4a bracket x minus h. So this one is the equation of the parabola where the vertex is located at hk. Now, we should note something concerning the eccentricity of various shapes. Let's say I have a circle and the focus is at the center of that circle. Then I have another shape called ellipse. This is ellipse. Then I have another shape here called parabola, which we just discussed now. And we have another shape here called the hyperbola. All being related to the directrix dd here. Now, if I draw a straight line through the focus, you can see that where each of the curve cuts, where the x cut each of the curve is called the vertex. Call this one vertex b1, call the vertex b2, call this place vertex b3, and this place vertex b4. We can see that the vertices move closer to the directrix, and then the value of eccentricity falls between 0 and 1. The eccentricity of a parabola is 1. Parabola. The E is equal to 1. And the eccentricity of a circle is 0. The eccentricity of a hyperbola is said to be greater than 1. So it's on this side of the eccentricity axis. And the eccentricity of ellipse falls between 0 and 1. No, sorry. The eccentricity of an ellipse, is between 0 and 1. 0 less than E and E less than 1. That's the eccentricity of an ellipse. So I believe that we've learned one or two things concerning the derivation of a parabola. Please do not forget to like, share, make a comment, and subscribe to my video. Once again, this is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Thank you so much. Have a nice day. Bye.